Hi everyone, I'm Mrs. Charles, and today we have two fun science activities for you to try. One involving chemistry, a chemical reaction, and one that shows off an important law of physics. And if anyone ever told you science isn't fun, these activities will prove them wrong. These are the supplies that you need to make the endothermic baggies. You need 1 teaspoon of citric acid, which you can find at grocery stores with canning supplies or at health food stores. A teaspoon of baking soda, a quart zipper-type plastic storage bag, a little water, and of course you need your teaspoon. Okay, now I'm going to show you what to do for the Endothermic Baggies chemistry activity. You take a teaspoonful of baking soda, and put it in the baggie, and you take a teaspoon of citric acid, and you're going to put that in the baggie. Now you'll mix it a little bit, just gently, and now they're all mixed. Now I have just a little bit of water in this glass. I'm going to pour it into the baggie and seal it very quickly because the reaction is going to happen instantly. So you have to be ready. So I'm going to be ready to seal this. All right, here we go. This is the fun part. Put a little bit of water. Seal the baggie. And you can see there's a chemical reaction. There's lots of fizzing and bubbling, and it's turning cold. So what's the science for this experiment? Sometimes chemical reactions between substances give off or take in energy, often in the form of heat. Chemical reactions that take in or absorb energy will decrease the temperature of their surrounding environment, which means it will get colder. This is called an endothermic reaction, and that's what happened here. Citric acid, this, and the baking soda and water react to produce or make carbon dioxide. The carbon dioxide gas fills up and makes the bag inflate or puff up. The liquid in the bag becomes cold. Once the reaction ends, the mixture returns to room temperature. How long did it take for your baggie to stop being cold? You might be surprised how long it takes. The opposite chemical reaction is called exothermic. Heat energy is given off during the reaction and the temperature increases or gets warmer. Now, to experiment yourself, try using different sized plastic baggies and different amounts of baking soda and citric acid. Time how long a temperature change takes. Remember to only change one thing at a time for each experiment. These are the supplies that you need to do the marbles game physics activity. You need 2 paper plates, a scissors, a ruler, a marker, some tape, and a marble. So this is what we're going to do first. Take your marble, lay it on your table. We're going to give the marble a gentle push, and you'll see that it goes pretty much in a straight line. Okay, now roll your marble on the plate, and you'll notice that it goes in a circle because the rim is stopping it from going in a straight line. Okay, so now I've drawn a red arrow to show the direction the marble goes around in a circle. Now I'm making a sample plate. I've cut out a pie shape. Think about which way the marble would roll when it hits the place that is cut out. Okay, I've added some arrows, blue, orange, and yellow. Which way do you think the marble will go? When it goes around the circle, will it continue to make a circular line and go on the yellow path? Or do you think it will go this way, the orange path? Or do you think that it'll go the blue arrow? Before you roll the marble to see the answer, make a guess, predict, or hypothesize. Think about science. That's what scientists do when they want to discover something. Now you need to cut your plate. Measure the plate, find the center. My plate is 8.5, so I'm going to put a little line at 4.25, which is about half. And then I'm going to do it this way, measure it this way. 8.5, find 4.25, which is about here. So here's my center. Then I take my ruler and make a line this way. And it doesn't matter what size your pie shape is. So go like that. Then take your scissors and cut on the line. All right, there you go. Now you're ready to roll your marble and test it to see which path your marble will take when it hits the cutout portion. Okay, now I'm going to roll my marble and see which path and which arrow it actually takes. Okay, what's happening? What's the science? Inertia is Newton's first law of motion. An object in motion will continue in the same direction and at the same speed unless another force changes it. When you roll the marble in a straight line, it will go straight unless something changes its direction or slows it down or speeds it up. That's Newton's first law of motion. Here it goes straight because nothing else moves it. Now, when you roll the marble around the whole plate, the rim pushes it in a new direction, causing it to move around the circle. Here it curves because something else moves it, the rim. This is also Newton's first law of motion. When you roll the marble on the plate with the cut slice, the marble follows the plate rim in a circular path and won't stop the circular direction until it gets right to the edge where the plate is cut away. Then, because the rim is not there, the marble will follow the law of motion and again roll straight across the table. It will follow the orange arrow. You can make this into your own game by taking the cutout slice and placing it so that the marble will travel from the larger plate to the smaller slice. You'll need some tape to hold the plates in place. And I'm going to tape this one here because I think my marble would be able to go from here to here to here. You'll have to experiment with how hard you push the marble. If you push the marble too hard, the marble will jump the plate rims. You could even cut out more plates and make different shaped slices and try to get the marble to go from plate to plate to plate in 3 different directions. When you play with all of the pieces, you will notice that the marble will slow down. Do you know why? Friction. You'll especially notice this if you play on the carpet. Well, that's it for today. I hope you had fun with both of these activities. We'll see you next month for another I Spy Science and Wired for Science activity.